Hey there! So last time I showed you how we can set up this CI/CD pipeline for the Azure Data Factory that is built using Azure Resource Manager templates. And it's pretty simple, it's quite easy to set up. In many cases, this setup will work just fine. However, there might be cases, and it was a real life scenario in my case, in case of which this approach will not work. Mainly because you might be required to deploy only a subset of ADF objects, like only a set of pipelines, not everything. And this ARM-based CI/CD will not work because it deploys everything. It's not possible to be selective. Fortunately, that's where ADF Tools come in. It's a set of great tools created by Microsoft MVP Kamil Nowiński that makes this possible. And that's the topic for today. So let's get started. Alright, so I told you that using ARM-based CI/CD process might not work sometimes. So let me actually describe this use case when it might not work. And actually that's a story from one of my projects. So, as usual, we have our Git integration enabled in ADF. This black line is our main branch, our collaboration branch, like so. And I will show you the behavior when using the old approach, the ARM-based one, what issue there were. So in this case, let's assume that we have two separate teams. Two teams of developers working on the same instance of Azure Data Factory for whatever reason there is, that work on independent features. And those features, they have a different life cycle. They have to be deployed and developed using their own pace. And the issue here is that those various development teams, they might block each other, and I will show it to you. So let's assume that we have a team 1 that would like to start implementing their features. And what would they do is to follow our basic flow. So they will create their own branch in Azure Data Factory. So let me call it team 1 branch. They will make various changes there, various commits. They will implement whatever they need to do. They will test it locally using a debug mode. And finally, when they are ready to go, when they want to promote this part of code to other environments, they would create a pull request to main. And pull request, just to remind you, is simply a thing when you say my part of the code is ready to be promoted. I'm confident that it is good. So this pull request would be then reviewed by some code reviewer, will be either rejected or approved depending on the situation. And then what would happen is that automatic CI/CD pipeline would kick in. Why? Because it listens for every change made in the main branch. So this is where our automatic CI/CD will start. And it would follow those various stages. First, it would build a package. And in this case, our package is simply this ARM template that contains a definition of the whole data factory and every object that is stored inside. Then it would be deployed automatically to dev environment. Then it might be deployed. Let's add one more environment to UAT, obviously after some approval. And let's assume that this UAT environment is used to test these new functions, these new features by business users. And finally, if everything is fine, those changes would be deployed to prod, again after approval. And let's assume that that's the path that was taken here. So the pull request has been approved, it was merged, the template has been built, it has been deployed to dev environment, some integration tests were performed on this environment, and right now this change has been deployed to UAT environment and it is being verified by business users. But the thing is that this change is quite big and it takes time to be properly verified by business users. So this flow stops here and waits for approval. In the meantime, we have a second team of developers working on the same instance of Data Factory. And there is a completely different story why they use the same instance, why they don't have separate instances. But let's assume that in this case, they have to work on the same instance. So what they would do, so simply they would follow the same steps as the first team. So they would create their own feature branch, again from main. So this is team2 branch. They would implement their own changes. And finally, when it is tested and verified by developers, it would be merged into the main branch. Then, after the merge, automatic CI/CD pipeline will kick in, like so. That would follow exactly the same steps as the pipeline for the first team, because both of them use the same pipeline, the same definition. So it would start with building our ARM template, then it will deploy it to dev, then to UAT environment, after approval, and finally to prod. So exactly the same steps. And let's say that those changes made by the second team are smaller, are easier to be verified. So let's say that the build stage went fine, deployment to dev went fine, it has been tested by some local testers, then it has been deployed to UAT environment, and here our business users were more proactive and they finished their approval faster than the change for first team. So this one is done. So we've got a green light to deploy the changes made by the second team. We have a green light to deploy them to prod. But can we just approve it here? Not really. Why? Simply because this ARM template, this package that was built as a result of Team2 merge, it also contains all those changes that were made by the first team, because they already merged into the main branch, and our second team, well, they created a branch from the main one. But the problem is that those changes from the first team, they are still being verified. Maybe there are some issues. Maybe something doesn't work as it should. Maybe there are some bugs. And therefore, team 1 is blocking every other team from deployment to prod. And that's a real problem in this approach. And actually, it doesn't have to be a separate team. Maybe it is simply a separate set of features that block the deployment. And in such case, you would have to somehow make sure that the change you want to promote to production environment, it doesn't contain those changes from the first team. So how it could be done? Well, there are some options. One of them would be to create a separate branch, maybe like so. Create a branch for Team2 deployment branch, and take note that it was created from the main branch, but just before the changes made by the first team were merged back into it. So our green branch, this one, it doesn't contain those changes made by the first team, but also it doesn't contain changes made by the team 2, those blue ones. So if we would like to have them in our branch, what would have to be done is to merge those changes into our green branch, like so. So at this moment, our green branch, it will contain only the changes made by the team 2, those blue ones. Alright, but then if we just merge it back to the main branch and just approve the process there, it wouldn't work either, right? Because those changes merged this package built from the main branch, it will again contain those yellow changes, so it won't work. So what would have to be done is to run a CI/CD manually from our green branch, and then the package built from this green branch, it will contain only those changes that we want. But you can see already that this process is not that straightforward. It requires some manual actions. It requires some cooperation between various teams to know what is actually being verified on which environment, what changes have been merged into the main branch, and in case of bigger projects, in case of multiple teams, this maintenance, it might be problematic. And the whole goal of CI/CD pipelines is to make our lives easier, is to automate everything as much as possible. So the deployment of our changes to other environments should be transparent to us. We shouldn't even have to think about this. And in this approach, as you can see, it will not work. So that's why this ARM-based template approach, it might not work in every case. Obviously, if you have small project, one team, then you're fine to go with this approach. But if that's not the case, that's where you can use those wonderful ADF tools. So what this is, this ADF tools. So let me write it down. So we've got ADF tools. ADF tools. Alright, so ADF tools is a set of scripts created by Microsoft MVP Kamil Nowiński that makes Data Factory deployment easier, more configurable, and just better. And in the video description, I will give you a link to Kamil's site where he has various videos when he talks about this solution, as well as his GitHub page where you can find the source code and documentation for ADF tools. And today, I will just focus on showing you how the CI/CD with ADF tools might look like from a developer point of view. In the future episode, I will show you how to set it up. So it will be quite similar to my approach to ARM-based templates. It will be split into 2 episodes. Alright, so how the flow using those ADF tools might look like. And you'll notice that the beginning is pretty much the same, at least in my implementation, in my way of using ADF tools. So let me start with our main branch that is marked as our collaboration branch in ADF. So what a team 1 would do, let's say that I'm a part of the first team and we have those multiple teams working on the same instance, and we want to be able to deploy only our changes to other environments and not bother about other teams that make some other changes and just go with our stuff only. So what I would do as a developer would be exactly the same as previously. So I would create my feature branch. Feature branch. Here I would make my changes, I would make my commits, add new pipelines, add datasets, implement the logic, whatever is necessary to satisfy our business requirements. Obviously, I would debug those changes using the debug mode just to make sure that everything works fine. And please note that this debugging stuff, it is still very important. You shouldn't just merge your changes without testing them first. That's one of the core rules in this approach. So actually, let me write it down so you would have it on the screen. That debug and testing it is still super important. So once I'm satisfied with my changes, I debug them at least as much as I could. I would create a pull request to the main branch, saying that, hey, I've implemented those changes. I tested them. I believe they work just fine. Please take a look at this, see if everything looks fine, and if yes, just deploy it to our environments. And as usually, during a pull request process, what would happen is a code review made by someone else, usually. We don't want to approve your own code because you might overlook your mistakes. What else we might enforce in a pull request? Like, we might enforce that every pull request has some work item linked work item. And here by work item, I mean some user story task or a bug from your backlog. In the case of Azure DevOps, that's pretty simple because it can be used not only to store our code and build pipelines, but only to maintain our backlog. We might also want to make sure that all comments are resolved. Resolve comments. Why? Because pull request approver, it might have some questions to the author. He might ask, hey, why did you do this in this way and not in the other way? And he would simply create those comments, and we want to make sure that every of those comments is resolved before the merge can happen. But let's say that everything is fine, the change has been approved and merged into the main branch. Alright, and what happens next is again that automatic CI/CD pipeline starts. So we would have a CI/CD that listens or waits for every change made in the main branch. And still in this case, our main branch is protected, meaning that the only way to make any changes in it is to do it via pull request. We don't allow any direct commits, just to make sure that every change follows this pull request and code review process. Now, what changes compared to the previous approach is that our CI/CD pipeline will no longer use those functionalities used to deploy and build stuff using ARM templates. No, here it will use ADF Tools, which changes the way it works. Mainly, ADF Tools, it doesn't use ARM templates anymore. Why? Simply because ARM template contains everything, and here we want to be selective. But if you take a look at a repository of your data factory, you will notice that actually every object is stored as a separate JSON file. So what ADF Tools does is simply it grabs those JSON files one by one in correct order, that's super important, and then uses APIs or PowerShell modules to deploy them. And that's it. So we no longer deal with this ARM template, we work with JSON templates, with JSON files. Fortunately, all of this is hidden or is taken care of by ADF Tools. We don't have to think about the proper order, about the dependencies that exist between our objects. For example, if we have a pipeline and a trigger, then obviously we have to deploy a pipeline first before the trigger. Similarly, if we have a linked service and a pipeline, and pipeline uses this linked service, then we know that the link service should be deployed first. And determining this order, those dependencies, it might not be an easy task, and it's not. But again, it is taken care of by ADF Tools. And to be honest, that's one of the core reasons why Microsoft says that they don't allow for selective deployments, because of those dependencies, that you might forget about deploying something that will break your data factory. But here it is taken care of. So under the hood, our CI/CD pipeline, it uses this ADF Tools. So what it does is that we no longer have to build our package, because we no longer work with ARM templates, we work with our JSON files that are already stored in our repository. So the first step my pipeline does, it deploys our code to dev live ADF. But at this moment, I deploy everything, all objects defined in my data factory. So it deploys everything. And secondly, it uses JSON, or to make it more explicit, I use ADF Tools. Alright, but why do I deploy everything here to dev? Well, simply because I want to have my dev environment in sync with my collaboration branch. So basically, whatever is merged into the main branch should be instantly deployed to my dev environment. So if you think about it, the end state or the effect of this merge into the main branch will be exactly the same as in case of ARM-based approach. In both cases, everything that is in the main branch will be automatically deployed to dev live ADF. What differs is the method used to do the deployment. But then, contrary to the previous approach, my pipeline stops. It doesn't do anything else. It doesn't go to UAT or prod environments. Why? Because this pipeline is used only to synchronize main branch with the dev environment, and it grabs everything. If I would like to deploy only my changes to other environments, I would use my selective pipelines that are configured in a way that they would focus only on my objects, not everything. So that would be the first step. Just create a pull request, merge it to main branch that would deploy it to dev environment. And actually, let's start implementing this. And then we will later see how to deploy it selectively to UAT or to prod. Alright, so what I have here is my dev instance of Data Factory that right now has some objects defined. And I already organized the objects, I mean pipelines and datasets inside my Data Factory into directories, just to clearly indicate which areas are maintained by which teams. And here, this folder team1, both for pipelines and datasets, it is maintained, well, by the first team, obviously. And that's the area inside which this team will make changes. And then those areas will be deployed by my selective pipeline. Likewise, we have area or objects maintained by the second team. These two. So we have a clear indication where given team can work. And creating such structure inside Data Factory makes writing those selective CI/CD pipelines easier. Because later on, instead of listing explicitly every object that should be deployed, what you could do is to simply indicate, hey, I want to deploy everything that is stored inside my team1 directory. and ADF Tools will take care of the rest. But that's in the future. So let's say that I'm a part of team 1 and I would like to create a new pipeline. I would like to implement new logic. But obviously, I'm not going to do this in the main branch because we want to follow our CI/CD flow or our Git flow. And I will create a new branch. Feature team 1 feature 1, like so. Let's create it. And now I switched to my feature branch. So let's go into my folder, my directory for my team. And inside it, let's create a new pipeline like team 1 feature 1 pipeline or whatever. Naming convention is not important at this moment. In your real life projects, you should have one that you would follow. Here, I'm just making it up on the fly. Alright, so let's add a very simple wait activity, dummy activity, that will pretend that actually that's our logic. So, as always, we would debug this change locally on our branch as a developer, and if everything is fine, obviously I would save it. That results in a commit to my repository. So in our flow, let me indicate it. We are here. We made our feature branch. We tested the change locally. And what I would like to do now is to merge those changes back into the main branch. So how to make it possible? Well, I would create a new pull request to main branch. Let's just go with those auto-generated names that are fine. I want to quickly go through these steps. I talked about this process in more detail in previous episodes, so if you're not sure how it works, just revisit those videos. Alright, so the pull request has been created. Let's say that I'm the approver, I'm the reviewer. I checked whether everything looks fine. It does, so let me approve it. And let me complete the pull request. Now, usually, we don't want to allow the code author to be able to complete the pull request. But here, for simplicity, to make it faster, and because I'm the admin, I will override this policy and I will approve it on my own. Alright. So right now this code is being merged into the main branch, and it already happened. And what I have configured here are two pipelines. This time I have two. The first one that is running right now, called the whole ADF, is the pipeline that waits for changes made in the main branch, and it starts automatically. So basically, this is this pipeline. And you can see that it has only one stage. And this stage is used to deploy my code to dev environment. And inside, you can see, or actually in the next episode, you will see in more details that it uses ADF Tools to make the work done. And let's wait a second for it to finish, and then we'll see how it works. And actually, it's already deploying my changes to dev environment. And what is super nice about this ADF Tools is that it provides a lot of information about the steps it does. For example, in this case, let me go back to this deploy step. I can see exactly that my data factory, it contains 8 objects. It has some pipelines, it has a linked service, it has some datasets, and it has a data factory definition itself. And this pipeline, it deploys everything, 8 out of 8 objects, because at this moment, I want to deploy everything. It is not a selective deployment yet. But it went fine, at least according to this pipeline. So if I go back to my dev live instance, I should see this new pipeline deployed. And yes, this is it. That contains this wait1 activity. Great. So it means that my dev environment is really in sync with my main branch. Alright, so that's cool. In the meantime, let's pretend that we have another team that also would like to implement their own changes. So what they would do is, again, they would create their own feature branch, like team2 feature branch. They would make their own changes, and then they would debug it locally and create a pull request. That would again result in automatic CI/CD. The same pipeline would be triggered, and that would deploy it to dev environment, and then it would stop. So actually, let's simulate this behavior. So let me switch back to the Git mode. Let me create a new branch for team2 feature team2 branch that is based on the main branch. And please note that at this moment, I'm in my branch for the second team. At this moment, I already have the change made by the first team, because it was already merged into the main branch. But me, as a part of the second team, I don't care about it, because what I care about is this area and this area. So actually, let's add a new pipeline for team2 super update. And actually, let's use a different activity this time. Something different than wait. So I will use set variable, and to make it work, I would need some variable like test of a string type. That's fine. Let's just do it like this. So let's pretend that this pipeline actually it does some logic, that it makes what it should do. All right, so I debugged it. Let me save it. So it results in a commit in the repository. And let's finally merge it back to the main branch. So I will create yet another pull request. I would review it, and let me simply approve it. Yes, I'm the admin, so let's override the policy. So the change is being merged right now, and after it is merged, the automatic CI/CD should start. It is already running. That again will grab everything that is deployed, that is merged into the main branch, and it will deploy it to the live dev environment. So in a second, in our dev environment, I should see both changes deployed. The one that was done by the first team, the green one, and the change that is done by the blue one, the blue team. So let's see how it goes. Whether it deploys successfully, and it is done. And again, if we take a look at list of objects that were deployed, this time we've got 9 of them, and 9 out of 9 have been deployed. And 9 because we added this this team2 super update pipeline that is new. All right. So now we are at the state when both changes made by both teams are merged into the main branch. But let's pretend that again I'm a part of the green team, team 1. I would like to deploy only my changes to dev, UAT, and prod environment. So what I would do? Now, in this case, how I work with ADF Tools when I want to make my deployments selective is that I create as many pipelines, as many CI/CD pipelines, as many teams they are, how many areas, how many domains, or whatever, however you want to call it. So in this case, I have a pipeline created for team 1. And what I would do would be simply run my CI/CD pipeline, but run it manually, not automatically. And what is important about this pipeline is it is selective. It is already configured in a way that it will look into those team 1 directories inside Data Factory, plus some shared objects that are necessary to make it work, like a linked service and the factory definition itself. What is also important, that I would create as many such pipelines, as many teams there are. So there are per team. And what this pipeline would do, well, it's simply deploy to dev, but this time not everything that is in the main branch, but only those objects that are explicitly configured inside our pipeline definition. Then it would deploy to UAT and finally to prod. Obviously, if it is approved by someone. Now, you might wonder, alright, but why do you want to deploy it to dev again? Because this change is already there. And the only reason to do this is to make sure that the whole process works just fine, that we didn't make any mistake inside our pipeline definition. So let me show you how it looks like. So inside my pipelines in Azure DevOps, I have this team 1 ADF pipeline, and that's the pipeline that is configured already to deploy only those objects that are important from team 1 point of view. In a future episode, I will show you how it is set up. Right now, let me just execute this pipeline. And I want to make sure that it runs from the main branch. And it is important that usually we want to do this from the main branch, because that's the collaboration branch. That's the branch to which all other changes are merged. So let me run it. And you can see already that it has 2 stages: deployment to dev and deployment to prod. For simplicity, I skipped a UAT environment here, but in your case, most likely you would have UAT as well. So what happens is that, again, ADF tools are being used here under the hood to deploy my changes to dev environment. But in a second, you will see that this time, this pipeline will not deploy 9 out of 9 objects. No, it will deploy only a subset. So let's wait for this deploy ADF step to be finished, and then I will show you exactly what has been deployed. And actually, we can see it already here, that only 5 out of 9 objects have been deployed. And you can see that there are no objects from the second team here. And not because they didn't exist in the main branch based on which the deployment is made. No, they exist, but they are simply ignored because I don't want to touch them. I don't want to deploy them. It's not my responsibility to deploy objects from the other team. It is their task. My focus is only my area. And basically, I don't care about the other team, as long as we don't have to cooperate somehow. Anyway, you can see that what is deployed here is some linked service that is, let's say, shared between all teams. We've got my 2 pipelines that were defined inside this team 1 directory. We've got a data set that was defined inside this team 1 directory. And we've got a factory definition that has to be deployed anyway. All right, and it went fine. So on dev environment, only my changes changes made by team 1 have been deployed. And if I switch to live mode on dev, well, I would see my changes. But honestly, at this moment, I wouldn't notice any change because all of this stuff has been already deployed. The place inside which I will see finally the difference is a prod environment. So let's switch to prod. Let me refresh it. And here you can see that actually I have only changes deployed by the first team. Changes from the second team haven't been yet promoted to prod. And at this moment, I don't want to promote them. I want to promote only my changes, only changes made by the first team. So what I would like to happen is basically I want to add this team 1 pipeline, the one that we just added. I want to deploy only it. So what will happen right now is that we'll use this selective pipeline for our first team and we'll say it, hey, it's fine to go to prod, but we don't want any of those team 2 changes to be deployed because maybe they are not ready yet to be promoted. We don't know and we don't care, to be honest. Alright, so let's get back to our pipeline and let's approve deployment to prod environment. And let's see what will happen. And basically this prod deployment, it follows exactly the same steps as deployment to dev environment. The only difference are parameters because as always, there will be some differences, usually in case of linked services. A linked service on dev environment will most likely have to point to some different resource than a linked service on prod environment. And actually that's one of the great features of ADF Tools, that it makes parameterization a lot easier than the ARM-based templates. Because previously we had to use this strange ARM template file, parameter file, inside which first we'll define what can be parameterized, and then we would have to provide those values. In the case of ADF Tools, you can quite easily parameterize basically every property we want, and it can be done super easily, and I will show it in the next episode. Anyway, in the meantime, my prod deployment has finished, and let me verify what has been deployed. And yes, only 5 out of 9 objects. And you can see here that none of the stuff made by the second team have been deployed. But let's verify this on prod. So again, I'm on prod environment. Let me refresh my data factory. And what I should see is this new pipeline that we've just added, we as a team 1. And secondly, there are no changes made by the second team. And this is a proof that indeed we can make our pipelines selective. Finally, that's something that wasn't possible in case of those ARM-based templates. And actually, if I were to summarize or indicate the single best feature of ADF Tools, then this is it. A possibility to deploy ADF selectively, not everything. For me, this was a killer feature because I needed this in my project. But please be aware that this is not the only benefit of using ADF Tools. There are some other cool features out there that I will talk about in the next episode. And apart from that, I encourage you to go into documentation to read about them. Some of those nice features might be a lot of configuration options. So in case when you use ADF Tools, you have an impact or you have a power to decide how it would behave. For example, what should happen with an object that was removed or renamed? Do you want to keep it or do you want to remove it? in the ARM-based version, it would be simply removed. Here, you have a choice. But it also means that the behavior might be different between the ARM-based deployments and ADF ones. So if you switch from ARM-based to ADF Tools, you might be surprised that it behaves in a different way that you are used to. And it's because you configured in this way. So what I advise you to do is to practice or play around with ADF Tools on some test environment, just to familiarize yourself with all those options, just to understand what they do and how it behaves, how they impact the behavior of deployments. The other cool feature is that you have finally impact on a trigger state. You can define whether they want to be started, maybe not. Do you want to keep the previous state, how they were enabled or disabled in the environment before you did the deployment? Or maybe you would like to match the state that is defined in the source code. It's up to you. You can configure it. You have the power, you have the choice. Yet another cool feature is that in case of big data factories that have a lot of objects, it might take time just to deploy those objects one by one. And ADF Tools has this incremental mode, in case of which ADF Tools will actually compare what is deployed on a given environment with what is in your source code, and it will determine whether it is actually necessary to deploy a specific object. If not, that it will skip it, which will make the deployment shorter and faster. So there's a lot of options available inside ADF Tools that can make your life easier. But again, please be aware that the behavior might be different. So make sure to practice this. And if you are not sure about one of those configuration options, what it does, how it behaves, please refer to a GitHub documentation where Kamil did a great job in describing this stuff. If still something is not clear, then you can write a post in GitHub and he will respond in a timely manner. For me, ADF Tools is a great thing, and I strongly encourage everyone to at least try it out to see if it won't be a better choice in your case. Alright, and that was it. It was a short introduction to ADF to show you what issues it can solve. And today I focused on this on selective deployments. And before I finish this episode, let me show you one thing, that actually this parameterization is still possible. So I have this team1 pipeline that on prod has description called description for prod environment, super intelligent description. And on dev environment, I have the same team1 pipeline, but here it has description for dev environment. So there's a difference between both environments. It is simply used to indicate that you can parameterize everything in a very easy way, and I will show it to you next time. So that was ADF Tools, open source free piece of code that you can use to deploy your ADF in a more controlled way. And actually, ADF Tools are even mentioned in official Microsoft documentation that, hey, we as Microsoft, we recommend using these ARM templates to deploy stuff, but there are some alternatives, including ADF Tools. So take a look at it. And in the future episode, I will show you how to set it up. So that's all for today. Thanks for watching and see you next time. Take care.